Welcome to Math with Malia. Today we're doing Savvas enVision Algebra 1, Topic 1, Lesson 3, Solving Equations with a Variable on Both Sides. After this lesson, you'll be able to write and solve equations with a variable on both sides to solve problems. And we'll learn a new vocabulary word, identity. For our Explore and Reason, we have this situation. Some friends want to see a movie that is showing at 2 different theaters. They plan to share 3 tubs of popcorn. So the only information that we know for sure is the ticket price and how much popcorn they're going to buy. We don't know how many tickets or how many friends are going to see the movie. So we're going to write an equation for each theater and compare the two. For theater A, it's $14.50 per ticket. I'll use the variable T for ticket. Plus they're going to have the cost of popcorn, so 3 popcorns at $5.75 each. So here's our equation for theater A. And for theater B, the ticket price is $13 per ticket, I'm using the variable T again, and the cost of popcorn would be 3 times 6.75. If we set these two equations equal to each other, we can solve for T the number of tickets it would cost. Okay, so starting with our theater A equation, 3 times 5.75 is $17.25 for popcorn. And on the other side, we have our 13 tickets, and 3 tubs at $6.75 is $20.25. Okay. We have a variable on both sides, so we need to move our variable term to the other side and our constants to the opposite side. So if it helps, you can draw arrows to know which way your terms need to move by doing the opposite operations. So since I'm moving 17.25 to the right side, I'm going to subtract, do the opposite of adding 17.25. I will subtract it from both sides because of the property of equality. And since I'm moving 13t to the other side, the opposite is subtracting 13t. So you can do it in one step as long as your variable terms and your constants are going to opposite sides of the equation. Okay, and then I have 1.5t. That cancels, equals $3. And dividing by the coefficient on both sides, the number of tickets where the cost will be the same at either theater is 2 tickets. So if 2 friends go, then it doesn't matter which theater they go to. But what if they go with 3 friends? If T was equal to 3, we could plug that in. We could plug in the variable 3 and calculate the cost using our 2 equations. So if we plugged in T equals 3, then for theater A, our cost would be $60.75. So if I plug in 3 in here for T, I would get $60.75 for 3 friends to go to theater A. If I plug in 3 into the theater B equation, and I multiply 13 times 3, and I add $20.25, then that cost would be $59.25. So it would be cheaper to go to theater B if 3 friends went. And you could do the same if only 1 friend went, but obviously 1 friend is not going. So they should choose theater B if 3 or more friends are going. All right, example 1. We're going to use algebra tiles to have a visual display of how to solve equations with variables on both sides. What is the value of x in this equation? 2 times x plus 3 equals 3x plus 2 plus x. So you can see we do have a variable x on both sides. Okay. So using algebra tiles, I'm going to zoom in. Using algebra tiles, x is the green bar, and then each individual yellow tile represents 1 unit. Okay, so we have 2 of the x plus 3. So this whole thing right here is x plus 3, and I have 2 of those. And here we have 3 x's, 3 bars, we have 2, a constant of 2, and then we have 1 more x, 1 more bar. So if we rearrange them and grouped everything together, we have 2 x's on one side, 4 x's on the other, 6 ones on one side and only 2 ones on the other. And using the subtraction property of equality, we can subtract the same amount from both sides. So the 2 x bars will cancel out on both sides. 2 of the 1 squares will cancel out. Okay, that's what we did there. And that leaves us with 4 squares on the left and 2 bars on the right, 2 x bars. And since we can divide both of those in half, divide them both by 2, so I'm just cutting the amount in half, dividing by 2, so that leaves me with 2 single squares on one side and 1 x. So when we're solving for our variable, we want 1 x. Okay, so 1 x is equal to 2, and that is how we can solve an equation with variables on both sides, just applying the property of equality like we have before. What is the value of n in the equation shown? Now here we have a fraction as a factor outside parentheses, and so sometimes instead of distributing, it might be easier to get rid of that factor outside the parentheses. In this case, that would be easiest is we get rid of 1/5. So to cancel out 1/5, we need to multiply by the reciprocal. So what we're doing here is multiplying by 5 over 1. That will cancel out that factor outside the parentheses. And since I multiplied by 5 on one side, I have to multiply by 5 on the other side. So we multiply the whole right side of the equation by 5. And then if we simplify, so the 1/5 will cancel out, and 5 times negative 7n is negative 35n. 9 times 5 is 45. That's how we got there. We multiplied both sides by the reciprocal of 1/5. Okay, then we're going to get our n terms, our variable terms, to one side, to the left side, and we're going to get the constants to the other side. So adding 35 to both sides, since it's negative 35n on the right, if I move it, I do the opposite, so I'm going to add 35n. Then moving the negative 6 to the opposite side, I'm going to add 6 to both sides. Okay, so that's how we get to that next step, is applying the properties of equality, moving the variables to one side and the constants to the other. We get 36n equals 51. Of course, we always divide by the coefficient on both sides. And then we get n equals 17 over 12. Make sure to always simplify or reduce your fractions. Okay, let's try it. Part A, 100 times z minus 0.2 equals negative 10 times 5z plus 0.8. So there's a couple ways we could do this. We could just distribute, or we could get rid of the factors outside the parentheses. So since 100 is a multiple of 10, I'm going to divide both by negative 10. So I'm going to just divide this side by negative 10, and because of the property of equality, I'm going to divide both sides by negative 10. Okay, so that's going to give us negative 10 times z minus 0.2 equals 5z plus 0.8. Now we can distribute. So negative 10 times z is negative 10z. Negative 10 times negative 2 is, times negative 0.2 is positive 2. And that equals 5z plus 0.8. Okay, and I'm going to draw my arrows again so you can see. I'm going to move my variable term to the left and my constants to the right. They don't have to go always to the left. It's just regular procedure to always have the variable on the left side. Okay, so since I'm moving 5z to the left, I'm going to do the opposite operation, which is subtracting 5z from both sides. Since I am moving the 2 to the opposite side, the opposite of positive 2 is negative 2, so I'm going to subtract 2 from both sides. And then we can add these two equations together. Negative 10z plus negative 5z is negative 15z. Okay, the 2's cancel, the 5z's cancel. That equals negative 1.2. And divide by negative 15, divide by the coefficient. Okay, don't forget, a negative divided by a negative gives us a positive. So z then would equal 0.08. All right, let's try B. I'm going to come over here and do part B. 5/8 times 16d, I better rewrite it, plus 24 equals 6 times d minus 1 plus 1. Okay, so in this case, multiplying by the reciprocal would not give us very nice coefficients. They would give us more fractions. So let's just distribute in this case. So I'm going to cross simplify as I'm distributing. So 5/8 times 16, they're both divisible by 8, so that would reduce to 1, and 16 would become 2. So 5 times 2 is 10d. Now I'm going to distribute 5/8 to 24. I'll do a different color. So 8 is a factor of 24, so if I divide by 8, I get 1 again, and 24 becomes 3. So 24 divided by 8 is 3. 5 times 3 is 15. Okay, so I distributed the 5/8. Okay, let's do the other side. Equals 6d. 6 times -1 is -6 plus 1. Okay, I'm going to rewrite it again so that we can combine our like terms. -6 plus 1 is -5. Okay, now we're going to move our variable terms to one side and the constants to the other. That means I'm going to subtract 60 from both sides, and then I'm going to subtract 15 because I'm moving it to the opposite side, so I have to do the opposite operation. Okay, I like to do it all in one. As long as I have my arrows going in opposite directions, you can do this all in one step. Add your two equations together. 10d minus 60 is 4d. The 15's cancel. Bring down your equal sign. The 6d's will cancel. -5 plus -15 is -20. And of course, divide by the coefficient. D equals -5. All right, example 2. We have another equation with variables on both sides, and we're going to use our algebra tiles again. So the first equation, 4x bars plus 6 single squares, and then we have 2 of 2x's plus 3. So we have our 2 of 2x plus 3. If we rearrange them, we can see we have 4 x bars on both sides, so those can subtract out. We can subtract them both from both sides. And then we have 6 single squares on both sides as well. So really, it's the same exact equation on both sides. Here we can see our final solution is 6 equals 6. That is always going to be true. 6 will always equal 6, so this is what's called an identity. Because 6 is 6. It is always 6. That is its identity. So in other words, there are infinite solutions. Okay? It's called an identity, or you can say it has infinite solutions. Any value of x, we can plug in any number for x, and it will work on both sides of the equation. All right, example 2, part B. We have another equation with variables on both sides. So if we distribute the 2. 2 times 3x is 6x. 2 times 4 is 8. Okay, and you can see we have 6x's on both sides, so we can subtract 6x from both sides. Those will cancel out. We subtracted 6x from both sides. Now we have -5 equals 8. That is never going to be true. -5 will never equal 8, so there are no solutions. There is no possible value for x that will make this true. So just make sure you're doing your calculations and your opposite operations accurately, because you want to be able to determine how many solutions there are. Okay, let's try it. T minus 27 equals negative times 27 minus t. Okay, so I'm going to rewrite it down here. We have a negative as our factor outside parentheses. There's an invisible 1 outside those parentheses. So really what we need to do is distribute that -1. So if I distribute the -1, -1 times 27 is -27. -1 times -t is positive t. Okay, what do you notice? Well, it's essentially the same thing. They're just in reverse order. My t is positive, my 27 is negative. So this is an identity. There are infinite solutions. Okay, part B. All right, part B. Let's distribute. 16 times 4 is 64. 16 times negative 3m is negative 48m. Okay, and here, negative m over 2 is the same as negative 1/2 times m. So I'm multiplying 96 by negative 1/2. I'm just dividing it by 2. So 96 divided by negative 2 is negative 48m. And then 96 times 1 is 96. We can see we have negative 48 on m on both sides. So we could add them. I'll show you. I'll write it out. We could add 48m to both sides. Property of equality. That means those would cancel out. That would leave me with 64 equals 96, which is not true. There are no solutions. All right, our application problem, example 3. Arabica coffee costs $28 per pound and Robusta coffee costs $8.75 per pound. How many pounds of Arabica coffee must you mix with 3 pounds of Robusta coffee to make a blend that costs $15.50 per pound? So we can organize all of our information in this table. It really helps. Our price per pound, okay, and the coffee blend is going to be $15.50 per pound. Okay, and then we're obviously multiplying the rate times the amount. We're going to use A as our variable for the amount of Arabica coffee. We know we want 3 pounds of Robusta. The total amount of the blend would be Arabica plus coffee, or A plus 3. Okay, so there's our total amount blend. We don't know how much A is, but we know we're adding 3 to it to get the total amount for the blend. So if we just multiply then the rate times the amount, we get 28A. For Arabica, Robusta coffee would be 26.25. And then multiplying our coffee blend rate times the amount of the blend would give us that. So there's our equation. Okay, so Arabica plus Robusta equals the coffee blend. And just using our property of equality to solve for A. First we distributed, so we multiplied 15.5 into the parentheses and we got 15.5a plus 46.5. Then we're going to subtract 26.25. So what we did was we're moving our constant to the right side, and then we're going to move the variable term to the other side. So that's what they did. Okay, so subtracting 26.25 from both sides gets us 20.25. Subtracting 15.5a from both sides gets us 12.5a. And then dividing by the coefficient, we solved for A equals 1.62. So we can have 1.62 pounds of Arabica coffee to blend with the 3 pounds of Robusta to make our coffee blend. All right, let's try it. How many pounds of Arabica coffee should we mix with 5 pounds of Robusta coffee? So let's write our equation again. We know Arabica coffee is $28 per pound. We don't know how many. We're going to call it A again for pounds of Arabica. We're going to add it to 5 pounds of Robusta, which is at $8.75. And this time we want our blend to be $12 per pound. $12 times, now we have our amount of Arabica, which is A, and we have 5 pounds of Robusta. So our total amount of the blend would be A plus 5. Same thing, we're going to just distribute and solve for A. Okay, so if I distribute the 12, I get 12A plus 60. Okay, 5 times 8.75 is 43.75. Okay, and we're going to move our variable terms to the left and our constants to the right. So subtracting 12a from both sides, make sure you line up your like terms. I can't subtract 12a from 43.75. I can only subtract it from its like term, the other variable term. Subtracting 43.75, same thing, line up your constants. You can't subtract a constant from a variable term. Okay, then add our equations together. 28a minus 12a is 16a. The 43.75 cancels out. Bring down your equation. The 12a's cancel out. 60 minus 43.75 is $16.25. divide by the coefficient, divide by the coefficient on both sides. A equals 1.016. I think we have more decimals, but I'll round to the thousands place. 1.016 pounds of Arabica, so not very much. We could double check by plugging that into our equation and seeing if both sides equal the same value, which they do. All right, another application problem. Cameron pays 95 cents per song with his current music service. A new music download service charges 89 cents per song with a $12 joining fee. Should Cameron switch to the new service? So again, we're going to write our word sentence to represent this equation. So we want to see where the two plans are equal. That's our break-even point. So the new service equation, 89 cents per song plus the $12 fee. Okay, so there's our new service plan. His current music service plan is just 95 cents per song. S equals the number of songs. Okay, and then we can just solve our equation using the property of equality. So down here you can see we're just subtracting. We're moving the variable term. This time we're moving it to the right by subtracting it. Okay, so we subtract it from both sides. 12 equals 0.06s. Again, divide by the coefficient, and we get S equals 200. So what does this mean? That means if he's going to download 200 songs, the two plans are the same. This is your break-even point. Okay, so which one should he choose then? If he plans to purchase more than 200 songs, he should switch to the new service plan because it will cost less than his current service. So how can we figure that out? Well, if we did 300, let's just try typing in 300 to check, or even 250. So if S equals 250, let's double check. His new plan would be 0.89 times 250 plus 12. Okay, and that would give us a total of $234.50 for the new plan. For his old plan, it's just 95 cents per song, so 95 cents times 250 would be a cost of $237.50. So yes, if he's doing more than 200 songs, it would be cheaper to go with the new plan. So you can just pick any number greater than 200 to check. All right, Cameron's friend tells him of another service that has $15 joining fee, but charges 80 cents per song. So even cheaper per song, but a higher joining fee. At what number of songs does this new service become less expensive than his current service? Okay, so we're using his current service again, which is 95 cents per song. We're going to look at the break-even point. Where are they equal? Because then if we go more than this break-even point, the new plan would be cheaper. Okay, so the new service then would be 80 cents per song plus 15. So again, I'm going to move my constant or my variable terms to one side. My constant's already there. So subtracting 0.8s from both sides. Okay, and I get 0.15s equals 15. Divide by the coefficient. Divide by the coefficient. S equals 100 songs. So the break-even point is at 100 songs. At 100 songs, either plan is the same. So if it goes more than 100 songs, it will be cheaper to get the new plan. So anything greater than 101 songs, or equal to, he could download 101 songs and it would be cheaper to go with the new service. All right, we've made it to the concept summary. Here's another example to practice if you need to review. So remember, it's helpful to write a word sentence, and you're looking for the break-even point. With a lot of these, when you have variables on both sides, you're looking for a break-even point, and then you're going to compare. You're trying to see which one is cheaper. This is a very applicable real-world situation that you'll see a lot, and you'll use this type of algebra a lot in your real life. Okay, so make sure and come back for lesson 4 and leave any questions or comments you have.